here with Tom Wysmuller, and we just finished our show about Superstorm Sandy, and Tom just got here at the end of it. And so while you're here, uh, we never got into how hurricanes form in the first place, and why was Hurricane Sandy so different? We talked about it being weird. So what's going on?
Well, let's start at the beginning. Hurricanes form when a wind zone of Earth called the Intertropical Convergence Zone moves northward. Now I'm talking about northern hemisphere hurricanes. And what happens is that the trade winds blow from east to west in the northern hemisphere and the southern. They're basically, the equator is turning underneath the trade winds, underneath the Earth's atmosphere. So the wind is always out of the east. But toward the end of the summer, the zone of that convergence drifts northward, and you get twists and eddies into that zone. And if you happen to have, or be lucky enough to have a thunderstorm over the Atlantic, it develops that twist. And that twist becomes a tropical low, and then it gets larger and larger, and it feeds on itself. Because hurricanes take the evaporated moisture that they get off the ocean and convert it into heat, and it fuels the hurricane. They're actually one of the great heat transfer mechanisms on the planet, because what they do is they take tropical heat from the tropical oceans and literally put it into their system, and then the hurricane, when it moves north, releases that heat further north, 40, 50, 60 degrees even. So that's how hurricanes form. You asked another question: what made Sandy different, or what made it big? Sandy got lucky. All right, lucky. When a hurricane gets big, they get. I call them lucky. Okay, it happened to stay away from land. When a hurricane moves over land, the moisture that it depends on for its life is taken away, or part of it is taken away. Sandy stayed over the open ocean. Not only did it stay over the open ocean, it stayed over a warm finger of the Gulf Stream, which was literally right under it. So now you had warm water fueling this hurricane. It got larger and larger and larger. Larger, I'm talking about in diameter, not in wind speed. Hurricanes have higher winds when they are actually smaller and more tightly wrapped. Sandy was huge, and it covered thousands of miles, the cloud shield of Sandy. The eye wall was very, very large, so the wind speed wasn't that great. It got up to Category 2 over the open ocean. Sandy was great because every meteorologist got it right. Every meteorologist, the National Weather Service, everyone knew where that hurricane was going. Usually hurricanes are very hard to predict. Even from day to day, they can't figure it out.
Why?
Because the winds themselves will steer the hurricane. The ocean currents, a differential in temperature will make it move. Lots of things can make a hurricane move, but Sandy got lucky. Sandy was barreling into a large high-pressure zone that was centered actually over Quebec. And the wind circling around that high circles clockwise. On the northern part of this high-pressure zone, you had the polar jet literally speeding that high up. It actually made it a stronger high because the 300-mile-an-hour winds of the jet stream pushed the northern part of that high into a higher wind, and it curved around, and when Sandy got into it, it got punched into...
So, well, you're talking about a high pressure in Quebec.
Right.
And Sandy is down in the Caribbean.
Right.
So we were talking
Well,
1,500 miles apart.
No. In the Caribbean, Sandy was just moving north, like all hurricanes do. That wasn't the problem. It was when it got off the coast of North Carolina, it began to feel the influence of that high, which basically was a wind pushing off the sea that was augmented by that jet stream on the northern end of that high. So when it was heading toward New York, it never had a chance to get to New York. It got punched into Toms River, New Jersey. And we knew that track about 2 days before it happened. It was great. You know, weather guys like to be correct once in a while, and this time they looked really good. Now I know I was on the radio with you a couple of times during Sandy,
Yes, that was great.
and I had access to the radars, so I knew exactly where the storm was. I could tell people where to evacuate from, and we did. If we saved any people, did they ever call in and thank you? I don't
They
know.
did. They did.
They did, good. Okay. Because we really gave them good advice. And I think I was within 4 or 5 miles an hour of gauging the top wind speed when it hit landfall, which was 115 miles an hour. And that was because the hurricane moving in toward Tom's River, moving from east to west, if you were on the northern end of the hurricane, you had regular 85-mile-an-hour winds, which was basically made it a Cat 1 hurricane, augmented by the forward speed of the hurricane. That's where you got the 115 miles an hour punch. And of course, that same direction pushed water into New York Harbor, flooded, as you said in your earlier broadcast, and it made an exciting storm. I mean, it was quite an event. The hurricane that we just had, Patricia, off of Mexico, was a unique storm. Now, Sandy was unique too because it was so large. Patricia was unique because it was so small. In other words, it had a very tight eye wall with very, very high winds.
Oh, that's why it was 160 miles an hour.
No, it was 200 miles an hour. In fact, there were reports of gusts 245 over the open ocean. And can you imagine what it's like to be on the open ocean during Patricia with 200-mile-an-hour winds, kicking the waves back and forth? If you're in a small boat and you happen to be unlucky enough to have two waves crash on you from different directions, all of a sudden you find yourself 40 feet underwater. You're gone. I mean, there is no more horrible place to be on Earth. Maybe inside a volcano would be worse. But other than that, on the open ocean in a 200-mile-an-hour hurricane. Now, what that does, the hurricane, usually the way we get moisture in the air, sunlight hits the open ocean, you get evaporation, and that's how we get moisture in the air, which is very nice. Hurricanes do it differently. Hurricanes, because of those high winds, they literally take the kinetic energy of the hurricane and basically brutally roil the oceans and punch these water molecules, add that energy to the water molecules, and then bang, they become water vapor. All right, so that they're and they condense it, and they get sucked in. They get to very high altitudes. They
Clouds are made of water vapor.
and that's right. And well, when the clouds condense, then the heat and kinetic energy that allowed that water to evaporate into water vapor then gets released into the surrounding air. Now, if you take a look at the Intellicast website today, and of course, I don't know when you're going to broadcast this, but you're not going to be able to see it. The entire eastern United States is under the remnants of this cloud shield that hurricane produced. Everywhere except New York and New England. And tomorrow you're going to get it here, by the way. So the entire East Coast is now basically benefiting, if you want to use that word, from the water that was kicked into water vapor off the coast of Mexico, is now condensing out, becoming rain, falling as rain, and when it condenses, it's called latent heat of condensation. That heat is then released into the atmosphere, and that's how you get the heat transfer from the tropics to temperate zones where we are right now. So the entire East Coast is going to be having a warm, gentle rain because it covers about 1,000 square miles of just pure rain. So if there was a drought before in this part of the country, forget it. It's going to get nice and wet, and that heat is going to be released into this part of the world. In fact, that heat is going to go north and further north. It's probably going to go over Greenland. And I don't know if you notice the New York Times.
What will it do in Greenland?
It's going to fall as snow. Because there's moisture content when it falls into cold air, falls as snow. It's going to replenish a lot of the water that was lost this summer. We had about a 2-month period We had temperatures actually getting into the 40s in Greenland. And the New York Times has a great, if you go online for the Times, they have a very, very neat article about Greenland, about some researchers looking at the moulins and sending drones over Greenland.
And the moulins are the waterfalls within the
Yes,
glacier.
and they fall within the ice cap. They go down under. They end up in the ocean, but they only last for about a month or two, because once it gets 30 below zero, 40 below zero, they all freeze. All right, but now you've got this moisture packet coming up there from this hurricane. Most likely, I'm going to be watching the world radar eagerly for the next couple of days, seeing how this moisture packet moves north. It's going to go in the Canadian Maritimes and very likely hit Greenland with a lot of snow. And you'll be measuring the snow there by the meter, not by the foot.
Now, you had mentioned that it was warm air going up toward Greenland and going from Mexico across the U.S. and Canada to Greenland. Now, if it's warm air, is that going to mean, because it's snow in Greenland, but what is it in between? Is that going to make more snow or melt the snow that's already there? Because late October, you get snow in northern Canada.
Now, it won't melt the snow in Greenland because it's already too cold up there.
Northern Canada.
Yeah, northern Canada. Actually, northern Canada got some early snow this year, and I'm going to talk about that when we do our annual forecast, because the geometry of the Arctic this year, even though there was ice recovery, the geometry of the open parts of the Arctic was such that a fair amount of early snow was deposited around the shores of the Arctic, and that means that the polar high is going to be larger this year. And that's going to have some implications with our forecast. I'll know exactly what it is next month, so I don't want to jump ahead.
Yeah, okay.
But again, this warm air can hold more moisture, and as it moves further north, it gets cooler and cooler and cooler, until finally it gets below freezing. But that moisture is still there, and that moisture will then precipitate out as snow. Sandy, again, was a beautiful, easy to predict storm for where it was going to go. I think it changed the way people in New York thought about hurricanes. We've had a lot of hurricanes here. The hurricane of 38, when it marched across Long Island and punched into Providence, Rhode Island, again, it also pushed a huge wall of water into Narragansett Bay.
That must have been a hell of a hurricane because...
the 38 storm, you mean?
Yeah, because when Catherine Miles was interviewing various people in the Weather Service, a lot of them keep mentioning the hurricane of 38.
Yeah.
And these people weren't alive at the time, but they know about it.
Oh, yeah. Well, the thing is, Providence, Rhode Island, there are buildings there that show watermarks 20 feet higher than the sea level there. 20 feet higher. That's huge. Now, why did New York think it was exempt? All right? So, and now, within a week after Sandy, the city of New York started revising its disaster plans, and then declared that 25 feet would be a 500-year storm level, something that they should have planned for a little bit earlier, because they could have protected those subways and the Brooklyn Battery Tunnel. Just a little extra forethought would have been enabled them to do that. They have it now. But they have it now. And you know, the people who did the landfill in the 1800s deserve some of the blame. You know that there's a circular structure in Battery Park called Clinton Castle. Now, Clinton Castle used to be in the water, and you used to have to walk along a ramp about 150 feet long to get to it. And it was great for tourists in the 1800s. When they built the landfill and built Battery Park around it, they didn't build it high enough. If it had been just 4 feet higher, the subways never would have gotten flooded. 4 feet is all you needed. And 4 feet is kind of minimal. In fact, where your studio was, that's the other street next to it is called Water Street. It's called Water Street because it used to be underwater. Yeah. All right? If you go a little bit further up, you walk up Fulton Street, and you finally get to where Manhattan really was. Yeah. And so...
you could see it when the storm, when Sandy happened, and you can look out the window and you look west on Wall Street, right, where we were, it had submerged the traffic light. So we're talking 18 feet, and you look down Wall Street within easy sight, and there's people
200 yards.
there's people walking around in the water, and it's up to their knees. And so it's like, wow, what a difference, And because when you walk down Wall Street, you don't think that you're walking down any big elevation, but you are. But anyway, I think it's getting late, and we've supplemented the Hurricane Sandy show pretty well. So thank you, Tom.
Okay, and I look forward to seeing you next month when we do the annual forecast. And
A lot of people looking forward to that.
well, yeah, I'm looking forward to it too. I want to get it right. I mean, I've done this 6 times, 5 times on the air with you. With some luck and a little bit of skill, I've actually nailed every one of them, and I feel really good about that. So thanks to you. If it wasn't for you, I wouldn't be doing this stuff.
Okay, thanks a lot. Thank you, Tom Wysmuller, and thank you, Environment TV.